All right. So today we're going to be talking about constraints in relationships. Part one, we'll talk about constraints that we can add to columns, which are rules that limit what is or isn't valid data for a column on a table. And then we'll cover relationships. And really, this foreign key constraint is going to sort of be our bridge from one to the other, because as we'll learn, both primary and foreign keys add constraints, but a foreign key is really the tool. And Tim, you were pointing out that we hadn't touched on this, that though it popped up in an assignment yesterday. A foreign key is really the tool that's used to set relationships between tables. And we got a preview of the different kinds of relationships yesterday in terms of thinking about it more conceptually in data modeling. And we'll get more hands-on today and write SQL code and show examples of implementing all of these different relationships. Any questions about today's agenda before we dive in? Cool. So I'm going to go ahead and I'm going to just connect to Postgres, and I'm going to create a database just named MyDB, just so I can do work in there. And I'm going to go ahead and connect to it. And over here, I've got an SQL file, and we're going to start building out some tables to add constraints, and then we can run our SQL as we go. So I'm going to start with the unique constraint and the not null constraint. And then we'll see how those sort of combined help create a primary key constraint that does a couple different things. So we're going to build out a student table. And just for the moment, we're going to pretend like primary keys don't exist. And so in my student table, I'm going to want an ID. I'm going to want it to be an integer. And that's a good starting point. And I'm going to add, in fact, I'm not going to add a semicolon, and let's run our SQL and we can see like what that error looks like. So I'm going to run my SQL file. Let's see if it created the student. And it in fact did. I actually thought it wouldn't create the student without.
Is it because it's the only table in the file? If you
Yeah,
created another one, then it would give you an error.
yeah, I think you're right. Let's in fact go ahead and do that. And in fact, we get this syntax error. And I just wanted to show this, as I know we've all seen this, but this is by far the most common error to make with SQL because it's such a huge gotcha. And in fact, there's got to be some sort of IntelliSense or something that helps with pointing this out. But if you don't end the line with the semicolon, then SQL doesn't know that this line is one line of code, and it tries to, from SQL's perspective, like this is what it's seeing, right? Which is not valid SQL because it doesn't know when one thing begins or ends and the next begins or ends. So I've got a student. I've added my semicolon where I want it. I'm running the code again. And let's take a look at our very simple student table. Not a lot in here, right? So constraints are rules we can set on columns that limit what the values can or cannot be. And for an ID, if we're pretending that that primary key constraint doesn't exist, something that's obvious is everyone has to have an ID. And indeed, this was sort of what I was racking my brain with yesterday Adding a constraint is really easy. We have the column name, we have the column type, and then we add our constraints after that. And now if I run this SQL again, we see that there's this not null constraint where if I try to insert into student ID, I'm not sure actually if this will work with, well, actually, I think we can do it like this. I get an error. And we see this error says null value in column ID violates not null constraint. And this is great, right? Because at a really low level for our data model and our application, we can set these important rules so that no matter whether it's my Python code or SQL or anything else, a student ID always has to have a value. And by the way, if I had done an invalid type of data, we'd see a very similar sort of error. Um, and I think the issue there may just be using single versus double quotes. And we see this error, invalid input syntax. It hasn't gotten as far to figure out that it's the wrong type. I think the single quotes are throwing it off, and it says, hey, for an integer, I shouldn't be seeing like quotes at all. If we do maybe like 4.37, we're either going to see another syntax error or we might actually get a sort of type error. I'm actually a little surprised that worked. But something very interesting happened, which is not that great. Postgres kind of made the executive decision to get rid of the decimal values here, right? And actually, I would have expected it to throw an error, and that's a little bit of a gotcha and something that's good to be aware of. But we know that this is not what we want, that in fact, we want an ID with a value of, say, 0. And lo and behold, we've got a student with an ID value of 0. And let's make a couple more students. Um, and this is great, except the whole point of an ID is it being unique. So let's add a unique constraint as well. And now if I run this code, note what happens. We drop the table from line 1 up here. We create the table. We have one successful insertion here. And then we have 2 failures, right? And these errors don't mean that my SQL is broken. It means that the data we're trying to insert violates a constraint. And we get a really nice error message describing exactly what constraint is violated. The duplicate key value violates the unique constraint, student ID, right? And if we change that, then let's see here, key ID 0 already exists. I should be dropping the table. Let's see what's going on. Um, there we go. I think I maybe just forgot to save my file. And now I've got 2 students in there with IDs of 0 and 1. And let's take a look at the student table, how it's described. And this is what I wanted to lead up to. So pay attention to the 2 constraints that we see when we do this describe block. We see here under nullable, not null. And under indexes, this student ID key unique constraint with something called a B tree that we don't have to worry about right now. And what we see here is the name of this index. And then we see the name of the column that the index is for here in parentheses. It's for the column named ID. And we briefly mentioned indexes yesterday, but can anyone remind me, like, what does an index do?
It makes the table quickly searchable.
Yeah, exactly. It makes it easier for Postgres to look up stuff faster. It's like, again, if you think about the index at the end of a book or something, where if you want to find where like a certain topic is, it tells you exactly what page to go to, right? And whenever we add new data into the database, Postgres will update the index. It turns out that this is also really useful for enforcing something like a unique constraint. So the way that Postgres enforces unique constraints is by creating an index for columns that we want to be unique. So that's our student table. Let me go ahead and make an employee table real quick. And our employee needs an ID. That's going to be a big int. Let's do primary key. And let's go ahead and run this SQL. Let's look at our student table again. And now let's look at our employee table. So there's a couple similarities here, right? This primary key constraint, it does a couple things. It adds this not null constraint, and there's an index created um, on the ID column that says primary key, but we can much pretty guarantee, I think this enforces uniqueness. And in fact, let's test this out right now. And we can do insert into employee ID values 0. And I think this will give us an error. And indeed, we see this error here that's coming from line 22 of our SQL. Duplicate key violates unique constraint. So we just kind of double checked and proved to ourselves that this primary key index also enforces uniqueness. So these are like three critically valuable constraints, right? Not null unique and primary key that combines those things together, as well as tells Postgres this is how to uniquely find something in the database. So primary keys do a little bit more, but I wanted to show how primary keys are built out of these not null and unique constraints. So I just want to check in to see if folks have questions, what's on people's minds, what people's thoughts are. How are we doing thus far? Awesome.
Wasn't there like a different way that was mentioned to do like the primary key stuff?
Great point. There is, that's more about making the primary key auto incrementing. There's a sort of older way to do that, which works fine, by the way, and it's what you'll see in our curriculum. And then there's a slightly newer way. And I'll get to those in a bit. But we can have primary keys that don't auto increment. I honestly generally recommend avoiding it. Um, and Chase, what you were talking about is if we want to, let's have a user table and we want to make this an auto incremented primary key. This is the new way using something called an identity column in Postgres. This is the old way, serial primary key. And again, they both work totally fine. The newer way is preferred, but our whole curriculum shows this slightly older way, and it will get the job done. So yes, if you feel comfortable, this slightly longer verbose way is the better way to do it, but it's not a huge deal. Both of these make an auto incrementing primary key. Does that help answer your question?
Yeah, yeah, it does. Thanks.
Yeah, for sure. In fact, let's build on our user table here. And let me go ahead and comment this out so it doesn't throw an error. Because there's other fields we have that we might want to add unique constraints to. Email is a great example where, I want an email field. I want it to be text. By default, varchar, I think, is up to 255 characters. So I think that's the default max. So I can leave this as is. I don't want my user's email to be null. And I want the user's email to be unique. Now, what about the user's first name? What do you all think here? Like, do we want a not null constraint? Do we want a unique constraint? What are people's thoughts?
I would just say not null with the limit of how many characters.
Yep, I would agree. Right? Because it's more than fine to have 20 people named Bob in our database. It's emails that have to be unique because they're emails and IDs that are our primary keys. And so now, render is just the name of a family friend. We should be able to have Bob's to our heart's content. And let's see here. It looks like I actually have, oh, I totally have some typos. Let me fix my SQL. I was moving a bit too fast. And let's see here. Insert into user, values, syntax error, line 32. I wonder, I don't think it's the trailing comma.
The trailing comma will do an issue. You'll
It
have an
does
issue.
cause an issue.
Yeah, kill it.
Thank you. I'm so used to the JavaScript best practices to add trailing commas to everything because you're always like adding stuff and it causes problems. Um, oh, the issue that we're running into now, I know what the issue is here. So this error relation employee already exists. Can anyone tell me why is this error showing up and what can I do about it?
You didn't drop the table.
Yeah, exactly. And why do I need to drop the table?
Because you're trying to create it every time you run the file, but it already exists.
Yeah, exactly. It's a little bit of a trick question, right? But if this table already exists, Postgres won't just overwrite it, it will throw an error. So since I'm kind of using this to build up my database and I want the SQL file to be the source of truth, I need this drop table if exists statement in front of everything. And now looks like we're still running into an error, but at this point, I think it's probably a relatively minor syntax issue. Drop table if exists user on line 26. Yeah, I'm not gonna, we'll see if we can't solve this one real quick and then we'll move on because I'm pretty sure this is just a typo. And in fact, I'm pretty sure it's not on line 26 because line 26 is pretty simple and it looks fine. Um, what this probably means is I have a syntax error with one of these other statements that SQL kind of can't deal with. So the way to debug this is the process of isolation. My favorite debugging strategy is I just comment stuff out until I get it to work because it helps me get closer to wherever the error is. And let's see if the error is in fact in that drop table statement. And it looks like it is, which actually surprises me a bit because I'm not really sure what the heck would cause an error there. And sometimes the answer is to just type it out again because it forces your brain to look at it with fresh eyes. And I don't think user is a protected word here, but maybe that's what we're running into. Yeah, so I think user may be a protected word in Postgres. That might be the issue that I was running into. Because if you'll notice, the error message has changed now. And this is actually what I would expect to see with the drop table statement. Table my user does not exist. Um, well, before our error message was error syntax at or near user. And I'm pretty sure,
Yeah, it is.
yeah, that if we look in here under the list of reserved words, indeed, user is there, which totally escaped my brain. Right. So that was actually good to see because it's a simple error, but the error message totally points us in the wrong direction. And that's where like this debugging process I think is useful because right, I was able to isolate and then I was like, something can't be wrong with this. And then that kind of led me to figure out what the real issue was.
I
It
think it's
does
great.
say you can use user, but you have to throw quotes around, like double quotes around the word user.
Yeah, that just sounds like an even bigger opportunity to shoot myself in the foot.
I think it's crazy how much time you can lose over something that's seemingly so simple, like when you're trying to solve problems, something like that. Like, why is that not working? And coming to the fact that it was a reserved keyword.
Right. Yes, it is. Yes, and that's very much just like the nature of the beast. And it is amazing how much time gets sucked into this stuff. Um, and let's see, first name. I'm not sure where the error is in the rest of this, and we've probably hit like peak value of debugging, but let's just see if we can't finish this off to get the my user table working. Um, and let's in fact just get rid of all this stuff. And now we should be able to add the rest of it in without losing our minds. I also broke my own rule here of always running my code as I go because I do make a ton of typos. So that's just a workflow habit I've developed. And I'm not sure what I was doing wrong there before. It doesn't really matter, to be honest. But now we've got a user with a name and an email. And we can see there that other unique constraint now has another index added because that's how Postgres does it. And we've got Bob. So let me just pause and check in and see if folks have questions because I got a little lost in the sauce debugging there. But I want to check in to see how people are feeling around using these constraints and also building IDs, right? Because the other way that we've seen to do this is serial primary key, and that will work just as well.
I'm thinking relationships will be more complicated than just adding constraints when we get to that.
Yes, relationships are definitely more. I want to show a little bit more constraints that we can do with some regex and some checking of number values. And then we'll kind of add some stuff to the game database from yesterday. And then we'll dive into relationships. So, and let me kind of switch over to my notes here. So another kind of constraint that we can do is what's called a check constraint. And the most common use case for this is regex for a field with text. And a good example of this is if we're going to make a table for, say, movies, and we'll give it an ID. And we'll do it the long way. And we'll give our movie a name. And it'll be a varchar. And I'll add this here. So again, I believe like that's the maximum size for a varchar, so we don't need to explicitly say it. And movie names should be unique, right? At least in our universe. And now I'm going to add a check constraint. And the way this works is I say the name of the column that we're doing our checking for. I use this sort of tilde thingy, this tilde symbol, which is how we tell Postgres that we're about to do some regex. And I am going to pull out to sort of help us with this regex, this nice site that we may have seen called regexer, where you can type in regex rules and see what they are. So I want my movie name to start with a capital letter. And it's down here at the bottom, it's a little hard to see, but this will match. It should be the first character, I think, to a capital letter. And then I just want to make sure that the rest of the characters in the movie name are letters. So we're setting some simple rules. And I totally am not pulling this regex from memory. I am terrible at regex. I am 1000% pulling this from the curriculum. And honestly, this is how I recommend doing regex is usually I will just be like regex for capital first letter, lowercase letters. I'll try to find a Stack Overflow that gets me close. If it's exact, great. If it's not, I'll grab it and I'll put it into regex or piece by piece. Regex is super valuable. Um, and some people get really into it. So if you do, more power to you. But I think the way to go is don't be afraid to look for others, but then take the time using tools like regexer to understand it. So let's put this in and then always add a note saying what the heck your regex does. Because let's say we have a typo here in the regex for some reason. Well, this might form a valid regex, but it doesn't do what we want. So the code can't communicate our intent here. So I need to tell other programmers what my intent is for something like this. We can do another kind of check. We can check numbers as well. And let's say that we want to do some sort of age limit check. And this check is a bit less useful, but it demonstrates the tool, which is, let's say that we want to make sure our like the age limit for the movie is you have to be between like 0 and 18 years of age. So this would be, I guess, if we're making a movie, it's not quite the same as PG-13, but saying like, hey, you have to be at least 13 years old to watch this, or at least 18 years old to watch this. And so the idea here is when we're adding a movie to our database, it doesn't say, hey, you have to be at least 500 years old to watch this movie.
Is between like non-inclusive?
That is a good question. I
So
think
I
it
mean,
is not inclusive.
if you're zero, it's legal then, but not if you're one.
Sorry?
So I'm just saying if it's non-inclusive, that would be like you could watch the movie if you're zero, but not if you're one.
Right. I think it is non-inclusive, which would actually mean we would want something like this so that if we wanted to have up to 18, that's actually a good thing to check. And let's just see if it's actually, we could probably even run some SQL, and that would be the easiest way to do it. You can also do this, by the way. So I could also say age limit greater than 0 and age limit less than or equal to 18. And in some ways that communicates intent a bit better, right? So both of these accomplish the same thing. And let's go ahead and just run this code. And let's see what we are running into here. And I just forgot a comma here, which is part of the problem with adding so many comments and kind of building it up line by line. And now we're cooking. And if we look at the movie table, we see a lot of interesting stuff, right? And we see our check constraints described. And we see our regex here and then our number check constraint here. And any questions around the check constraint? Cool. Let's kind of take this home and add a little bit of this to the game store. And then we can take a break and look at relationships. And I think what I'm going to do here is make sure I'm in the right spot. and we'll make a separate file for this. And let's open up a split and let's open up the CSV data so we can take a look at it as we're building this. So I've got my ID, and I'm going to hop over here and I'm going to steal this line for the ID because IDs are all sort of the same. And I'll name it game ID just to be consistent with the CSV headers here. And let's add a game title. And let's add a limit here that the game title shouldn't be more than 100 characters. A game title should be unique and it shouldn't be null. So just because something is unique and not null doesn't mean it should be a primary key. In theory, I could do this, right? Where, hey, every game title is unique. I can use this as a primary key. The term for this is actually a natural key. The idea being like this is a natural unique identifier, like email or passport number or social security number are all examples of potential natural keys. This is actually a bit of a bad practice because there's always some wrinkle that comes up along the way. It's easier to have control of primary keys. It's easier for them to be numbers. What if the name of a game changes? So try to, as a general rule, avoid natural keys. Let's also add a check constraint here. And I'm going to just put this on like the next line, just so I can kind of read this a bit more easily. And we'll add some regex. And if I look here, well, this does allow semicolons. Each of these starts with a capital letter. In fact, each word starts with a capital letter. So, and in fact, I've got a single quote here. So I want a regex that enforces each word starting with a capital letter, though the of in Call of Duty is an exception. I want to allow semicolons and single quotes. So this is actually a relatively tricky regex, and I'm totally not making this one up by hand here. But what we are doing is we're going to make sure that each word, I believe, starts with either a letter or a number. And I'm totally going to be putting this into regexer because this is a bit of a fancy regex. And regex is not my strength. And I believe what we're then allowing here is a number of special characters. And if we hop over to regexer and dump this guy in, there we go. Then we can kind of take a look and we can in fact see what every part of this regex is doing, which is awesome. And we can see that it's matching for these valid characters. It's allowing a number of special characters. And really it looks like we're matching against the beginning of the first word. And I don't, to be honest, I don't want to get too lost in the sauce with regex, but I just more wanted to demo a more complex regex. And to kind of continue building out our game table here. Well, a game has a quantity and it's an integer. I don't need it to go into the billions. So int instead of big int is fine. And we can say not null. Though in fact, if we were like building Steam and selling digital copies of games, then we might have to think about really high quantities, though this is for a physical store. And then we've got price. And this is going to be a decimal value. I don't want more than 2 decimal places, and my maximum price is going to be about oh, like 60 or 70 bucks. So again, I want this not null, but let's add a check. Right? I think between is exclusive, so I want between 10 to 60 copies is my sort of arbitrary decision here. And let's actually add a check here for quantity as well. And let's add a default value for quantity. And this we haven't seen yet. So this is new. And this does exactly what it sounds like. I'll put this all in one line so we can kind of see this. We can set the default value for a column. If I wanted to, I could add a default here, and I could add a default here. I wouldn't really want to, but just to kind of demonstrate this.
So your default value can be a value that doesn't fall between the check and line 7, for instance.
Oh, did it not fall between?
Well, I'm saying just because you have 0 as your default. I mean that would make sense to me anyway.
Oh, maybe I'm wrong about between being exclusive. Let's run this and find out because you're correct. The default value absolutely should fall between the check. And let's see, I have a trailing comma there. Cannot use column reference in default expression. I think the issue here is I keep wanting to use single quotes, and SQL does care about that. Single quotes have a different meaning. And we can see all of our indexes and rules, and let's test that out real quick, Jason, and then actually that'll be a perfect point to take a break. So we're going to insert into game. Let's just do game title, quantity, price. And I should be able to do default, default, default. I don't need to, but it is good to see because I might want to say, do something like this. Um, so what we could also obviously do is, in some ways, this is maybe the easier way to do it, is let's just add game title and we'll use default values for everything else. And let's go ahead and run this. And just one sec here. I just need a little more screen real estate so I can see what's going on. There we go. And let's add a drop table if exists game and run this one more time. Yeah, I'll double check if quantity is, we can actually find out right now.
I mean, it's not giving an error message, so it looks like it's good.
Yeah, I think it is inclusive. My bad. Yeah, and that's the game, and that's constraints. And after our break, we'll take a look at relationships. What questions do folks have around constraints the changes that we've added to the game table. I know I threw default in here as well, so I just want to check in to see if folks have questions around that as well.
I have a question regarding the check.
Yep.
Because it's all on the same line, you're doing like line 8 and 9, for example, quantity and not null, and then check quantity between. You be, would you think, can you think of an example when you would check a different value for that check?
Um, I would have to look at the details of how to use check, but
Or could you even say quantity and not null check uh price between something?
right. I think there probably is a way to do that, like check between zero. Yeah, I'm sure there is a way to do that. Um, I'm not sure I can come up with a good example off the top of my head, but we can actually do a quick search. Postgres check, uh, reference multiple columns.
Or even is the quantity necessary because it's all on the same line, or is it implied?
My guess is it's necessary. Let's Postgres check. And the answer here is to go to the docs and just see what the format that they have here. Default values and constraints can be listed in any order. A check constraint consists of the keyword check, followed by an expression in parentheses. The check constraint expression should involve the column thus constrained. Otherwise, the constraint would not make too much sense.
Hmm.
So,
So it's possible, but not recommended.
yeah, exactly. We'd have to dig a little more. And there probably is a scenario where you can maybe use another column, though I would get a little worried about Postgres interpreting that in the right order. Um, and I would have to dig. And a check constraint can refer to several columns. And actually, here's a good example, I think, of what you're talking about. Actually, this is a perfect example of what you're talking about, where they have a products table here, and they have a price, and they have a check on price. But then they also have a discounted price, which, by the way, is allows null, so it's essentially optional. But there's a check saying, um, interesting. What they've done, in fact, is they've added a check on its own line. So they have a check for discounted price, and then this is cool. Actually, I had not seen this before. Um, if we want to do a check with multiple columns, we can probably put this anywhere we want, but this is how they're recommending we write it sort of for our own sanity to check that, hey, let's make sure that price is always greater than discounted price.
Yep, that answers my question completely.
Yeah, great question. Great question. And this is I think a really good example of a use case for this. Right. So again, it kind of points to like the doc saying like, yeah, you can do it on this line, but you wouldn't want to. And a lot of stuff works that way. And again, I just like the metaphor of, we can do whatever we want with a screwdriver, but that doesn't mean we should use it as a hammer. But then as you see right here, we can do exactly what you're saying. Yeah, great question. Awesome question. What other questions do folks have? All right, let's break. Why don't we take 10, and then when we come back, we'll look at relationships. Sound good? Awesome. Thank you very much, everyone. Great questions, and I'll see you all in 10 minutes. All right, so we've covered constraints, and we went pretty in depth there, and we saw all the different kinds with not null constraints, unique constraints, how those kind of help form a primary key, and a lot of really cool stuff actually with check constraints. Postgres is pretty amazing. We're really just scratching the surface here. There's a ton of stuff that you can do. Let's talk about relationships. And let's start with the one-to-one relationship, and let's actually go back to our example here of passports and luggage items and flights. And we're going to stick with the conceit for now that we're just going to, I'm just so I don't have to type as much, frankly, when we're making table names. We're just going to pretend that all we get is a US standard passport and it's one passport per person. Um, so I'll kind of build this out. And then maybe do some additional drawing as I go, but I think I'm just gonna dive in and start writing code. Sound good? Cool. Um,
Are you going to cover the foreign key constraint later?
oh yeah, we're gonna be looking at that right now.
Oh, okay.
Yeah. It's kind of misnamed. It's a constraint, but it's also like the key tool for creating table relationships. So I kind of shifted it into this part of the talk. And just to get the ball rolling, I'm going to make a passenger table. Our passenger is going to get an ID and they're going to get a name. Um, and that's it, just to keep it simple. You know, we could also usually like an email is honestly more important than a name. But we're going to keep it quite simple. So now let's give our passenger a passport. And I'll add, and you know, I could add a to do here saying like refactor this to deal with different kinds of passports, but for now, there's just the one kind. And so,
You're going to get an error with your name having a comma at the end of it.
oh, thank you so much. Yeah, that is just so ingrained from all the JavaScript I've written. I appreciate it. Our passport table is also going to get an ID, but then there's also going to be a passport number. I think this it's letters and numbers, so we'll make it a varchar. We'll make it unique, not null. And now let's add a foreign key to connect our passport back to our passenger. And the way we do this is like so. We give the name of the column that we're creating, and the convention here is the name of the table underscore the name of the primary key on that table, right? So over here for the ID, that's what we're making this foreign key column reference. And actually, to pull back up my annotator, what we've got going on here is this is the name of our foreign key, and the naming convention is table name, column name of the primary key. But then that's just the name we're giving this column. We still have to tell Postgres the actual table that this foreign key references and the column name over there. And so this is the part that actually makes the connection. You know, I could name this whatever I want, but you don't want to do that because it will be incredibly confusing and other people won't be able to read your code. Let me add a couple drop table if exists in here so we can work with this file nicely. And I'm going to go ahead and run this SQL, make sure I don't have any typos. we can look at the tables, and then we can throw in a little data and play around with it.
I'm like 99% positive you need to initialize passenger underscore ID as a table thing first, and then you do the foreign key references.
Yep.
Say that again.
So in the passport table, you need to make a passport underscore ID int unique not null first, and then you can do the foreign key references. If that makes sense.
Um, Say that one more time.
So the passport table, you need to make passenger underscore ID its own like int
Oh,
variable first, and then you can reference that passenger underscore ID to the passenger ID.
got it. Got it. Okay. Yeah, I see. You're right. I think I got confused here. Um, and I think that, yeah, then because we're adding a constraint. My apologies. And no, I think that was you. Thank you. Let's try doing this the right way. Let's just do it like that. And we might add in the not null constraint in just a minute.
I mean, it's also unique as well, but I guess the unique is assumed then in line 14.
Yeah. Well, we'll get there. We are going to add those things in. So, yeah, and thank you so much for the fix there. My eyes were just not seeing that. Let's see, and this goes to the point, and this is where I was getting myself confused. What we're actually doing here is we're adding a constraint. So, like Noah, thank you so much again. We have to create the column, and then after it, we can add the constraint. And I actually wonder if this would work.
Does that mean you don't need a comma there like that?
I was wondering the same thing. I'm honestly not sure. Let's
You
find
you
out.
actually need.
Yeah, yeah, yeah. I think the column needs to exist before we can add a constraint for it. Um, oh, and that was just me putting something in the wrong spot. All right, so let's take a look at our passport table first. Um, a couple things happen here that are kind of interesting. So note that there's been an index created um, for the passport primary key that we're used to seeing. Um, an index for the passport number because it's unique that we're used to seeing. Now we see this foreign key constraint where we see that we see the name is like passport, passenger ID, F key, kind of combining all of these things. And then it says what it references back to. And we see here the table and the column name. And if I look at the passenger table, we see that the passenger table now says referenced by. And we see here, it tells us what table is referencing passenger, passport, um, and the constraint and what's referenced. And let's play around with this a little bit. Let's make a passenger named Alice. Um, let's make a passport. And we'll do passport number, but not our foreign key.
Is there a reason you're capitalizing the table that now you were using lowercase before when you were doing insert into? Does it matter?
Oh, it doesn't matter. I normally type it lowercase for speed. You see the SQL statements uppercased as a convention for readability. So something just interesting happened here. And as to the point you just made, I can only do so much uppercasing. Um, so just by itself, a foreign key doesn't add a not null constraint, right? Because I actually have a passport here that belongs to no one. Um, let's see here. If we do that again, we get an error. But let's add a passport that belongs to someone. So let's say Alice has an ID of 1, but let's say I want to give this passport to someone imaginary. Well, here's where the constraint part of the foreign key constraint comes in. Oh, my apologies. We actually are running into two issues at once. There we go. So this is the foreign key constraint part right here, where it says error insert or update on table passport violates foreign key constraint. Key passenger ID equals 12 is not present in table passenger. So what a foreign key does give us is, since it establishes a relationship between these two tables, if I do pass a foreign key value, it has to be for a passenger that actually exists. So it has to be a real existing valid passenger ID. Right? So if I do that, now we're cooking, and I can do select star from passenger, and that's the same. But if we look at passport, now I can see I've got a foreign key there with a passenger ID. So this goes back to the point that you were saying earlier, Jason, which is we probably want a not null constraint here on this passenger ID. The foreign key does not give us that right off the bat, right? And the way to think about this is like optional versus required. You might have a foreign key for something that's optional. Um, like for example, I don't know, my favorite food ID. And let's pretend we have some table named favorite food. Right. If our passenger, if our user had a favorite food and we wanted to have a list of foods to choose from, this is a good example of essentially an optional foreign key, right? It's not going to destroy our data model if we don't have a favorite food, unless we're building, I don't know, some sort of restaurant app. But because this data model deals with flights and passengers and planes and passports, having a passport that doesn't belong to a person is obviously not what we want. So in this case, we want to make this foreign key mandatory by adding the not null constraint as well. And I now should be able to run this. And let's see here. Did I introduce the syntax error? I did. I added the trailing comma because that's just such a habit. we're actually running into a separate issue here about cascading, which I'll talk about in just a minute. But I just want to check in and see if what questions folks have around creating a foreign key and the necessity of adding not null if we basically want to make this foreign key required.
So when you create that foreign key and like attach it to the passenger ID, do you have to like every time you're doing that, you have to explicitly say what passenger ID you're connecting the foreign key to?
Do you mean if I'm creating a new passport or, oh, like every time I'm
Yeah, like
creating,
if you created a new passenger, then you created a passport, but say you did that like 400 times, you have to do that 400 times for each person.
you mean like insert into passport, passport number, passenger ID.
Would you just, in that case, probably be feeding it a CSV file?
Yeah, Chase, do you mean like every time I'm creating a passport, do I always have to pass a passenger ID?
Um,
Or do you mean
yeah,
more like
I guess
creating?
I'm just a bit confused on like the foreign that line 15
Got it.
on like
Yeah,
how, but I guess like what Tim said, using a CSV file just makes a bit more sense.
yeah. Well, let's build another one of these. Um, and let me,
Well, I mean, Cascade would be important because if you go ahead and drop the passenger table, then the foreign key still exists in the passport, if you read it top to bottom. So I see how, the foreign key would be dependent on passport value would be dependent on passenger. So you'd almost have to, delete the tables at the same time.
yeah, I'm going to talk about Cascade in just a minute. I want to actually let's make a separate database here. We'll call it, we'll call it employees. We'll call it employee DB. And let me go ahead and make a new file here, and we'll call this boy. So I'm going to steal a little bit from over here, right? But rather than a passenger, it's going to be an employee. And just sort of for learning purposes, let's say for some reason we want to keep like the employees like social security information in a different table. And maybe what I want here is, oh, I don't know, employee info, right? Maybe it's like, or let's call this like maybe HR record. And here we're going to like store information about our employees. And so this employee HR record will have an ID, but I also wanted to have the employee's social security number. Um, so we'll call that employee SSN and we'll have it be a varchar. We'll have it be, I think it's 11 characters, and we'll have it be unique. And I'm going to get rid of my trailing comma before I cross this bridge. But I want to build a one-to-one relationship, right? So that over here is employee, and over here is employee HR record. And so let's build another foreign key. So again, not, and Noah, thank you again for pointing out, I need to create the column first. But now that it's there, I'm going to add a foreign key constraint to it. And I'll give it a name. I'll keep it simple. The name is going to be employee ID. And actually, I don't want to make the same mistake I did a moment ago. I need to create my column that is going to hold the foreign key. And we're going to say this is not null. And now in the foreign key constraint, I can say, hey, this employee ID column, it's actually going to reference another table. And specifically, it's going to reference the primary key there, the employee ID. And so now I have, again, a one-to-one relationship here between employee and employee ID. Actually, I may need to add a unique constraint here to make this a not a one-to-one, but we can cross that bridge in a minute. Chase, does this help answer your question? I think it was around like building foreign keys, but I'm not sure.
Yeah, that does. I think like so just like when a CSV gets inserted into here, that all happens. Like as long as the CSV file is set up properly, it's all going to kind of happen automatically.
Um, yes and no. Like if I've got an employee, right, I would create a couple employees like this. And how do I get from a CSV file to this? Well, you're correct. I think that copy command does some of the work for us. If all of the CSV names match the column names, um, and if like all the values match everything, which was sort of what we saw yesterday. Like if I open up, let's go to game.csv. So, you know, putting aside questions of foreign keys and stuff like that, um, like the fact that these CSV headers, that the names are an exact match for these table columns, is what made the import statement, I think it was with the copy command, be so painless, right? If that wasn't the case, we would be in trouble. And maybe this is kind of where you were going, which is, what do I do if, I've got some other column here and it's like genre ID, right? And there's some sort of genre table. How do I make sure all this works? Well, I would indeed, first of all, need to make sure that, like, if this is a foreign key, that data exists in the other CSV file and it gets loaded first. I'm not sure if that's what you were wondering about.
Yeah, that like smoothed it out a little bit.
Yeah. The short answer is it doesn't just do it for us. We do have to do it manually, and we will have to think about the order that we import CSV files and do stuff. Um, Python is a good intermediary, but we can still do a lot of this in SQL. But the order that we do things in does start to matter a bit. Um, right? The same way that, if I try to create this employee HR record table that references the employee table first before the employee table exists, it's probably going to throw an error. And similarly, if I try to insert into employee HR record let's see here, employee SSN, employee ID. If I'm doing these, before these actual employees with these primary keys exist, it'll throw an error. And similarly, if I'm trying to like copy some SQL, if I'm trying to pull in the employee HR record data from a CSV file before I've pulled in the employee data, then I will probably throw an error and run into trouble. So the sequencing of stuff does matter. I hope that helps address what you were wondering about a bit.
So when you're importing a file for certain tables, you want to create tables and essentially in your order that do not require foreign keys and have the tables that require foreign keys at the end.
Um, it, yeah, you don't need all the foreign keys at the end, but you do need some sort of order. Correct. Exactly. Like, like if we were doing this, I would want to, you know, import employee CSV data here. When you're writing your SQL, I would just kind of try to do all these like in one go. Um, and you are going to have to look and figure out, all right, like which table doesn't have any foreign keys that I can do first. And yeah, you're basically right. The stuff with the foreign keys needs to be towards the end. And actually, I think that's if to hop back to this passenger passport example, that's a good opportunity to talk about Cascade.
Before you move on,
Yeah.
after you create that table for employee, you can just do a \I import CSV data right then, right?
Yeah, exactly. Like right here.
Yeah.
Yep, exactly. And in fact, you would need to, if we want to then import, and in fact, I'll kind of put these insert statements up here. Um, and if and we need to do that first if we then want to import like the employee HR records. Um, and there's no way of getting around looking at the data, like actually to pull up this 64 slices assignment. Just to look at the data here. Let's look at like, I think it's probably orders. This is a great example. So SQL errors aside, there's a lot of foreign keys in here. Customer ID, store ID, toppings are sort of a foreign key. Pizza type sort of is. Um, and if I look in here, like all these values for the customer ID, it's a little hard to see, but it's like the second column. Um, you know, if I open up the customer CSV table, there will be customers in there that have those IDs, right? But if there wasn't, then we would have bad malformed data and we'd have a problem. None of the assignments we're going to give you have like bad malformed data that way, but it's always a possibility. But looking at this, I see, okay, customer ID, that's going to be a foreign key. Store ID, that's a foreign key. Before I can import this CSV file and have Postgres turn it into rows in my orders table, I'm going to have to make sure the customers table exists and the store table exists and that those are loaded and that data is loaded up, right? So you kind of have to work backwards. So just to use that as an example, and same thing with like probably deliveries, right? Deliveries, there's a driver ID but there's also an order ID. So before I can load this CSV in and create a bunch of rows in my table, I need to make sure that the order data is loaded. Does that help illustrate it a bit more as well? Yes, no, sort of.
Oh, yeah.
Okay, awesome. Yeah, the sequencing of stuff absolutely does start to matter. And Chase, hopefully that addresses your question a bit more. I think I understand more what you were saying now.
Yeah, yeah, it does.
Okay, awesome. And I think like a lot of this, like once you start doing it, it starts to click and it becomes easier. Let's talk about Cascade because that actually does relate to this. And let me just sort of hop back to our let's just rebuild this. There we go. So now I have a passenger table and a passport table. So let's say I decide, you know what, I want to delete the passenger table. I'm actually going to get an error here. Cannot drop table passenger because other objects depend on it. And then we see some information here about this foreign key constraint. So once we establish this relationship, Postgres is aware of it, and it's not going to let us get rid of the passenger table while other tables that reference it, that depend on it, exist. Because if we did that, it would totally screw up our data, right? Similarly, and let me get rid of this favorite food that we don't need. Let's add a passenger and let's give Alice a passport. And actually, I'm going to have to wait because I want to double check what Alice's ID is, though I'm pretty sure it's going to be 1. And that comma, that trailing comma is just getting me every time. And in fact, we're seeing this error pop up again because of this cascade rule. So I believe we can add cascade to modify that. But mainly, I just want to get a passenger in there. And in fact, I've got Alice in there twice, which is fine. Let's add a passport. And actually, we might have a passport already. So let's add a passport for Alice with ID number 1. So now I've got a passport in there. We haven't talked a ton about querying, but let's say I wanted to delete one of my passengers. The way I would do this is delete from passenger where ID equals 1, right? And that should delete our first Alice. But in fact, I get an error and it says update or delete violates the foreign key constraint because that key is still being used for that passport. Deleting the other Alice is totally fine, right? But to delete the first Alice, I actually have to first make sure I've deleted everything that depends on them, and then I can go ahead and I can delete Alice. So the term here is referential integrity. In that once we set up these table relationships, like Postgres won't let us delete stuff in a way that would mess things up, if that makes sense, that would destroy that referential integrity. The way to override this is with a term cascade. And I believe it actually should go. I think it goes there. We'll see if I have it in the wrong spot. But cascade means, hey, if I'm going to delete this, go ahead and delete everything else it depends on. That's okay. And so now, in fact, this worked. It gives us a heads up, drop cascades, and we've dropped the table, we've created it, we've dropped the table, and we've created it. So by default, Postgres won't let me delete data or tables that other things depend on by foreign keys. And if I want to delete them, I can use Cascade. In general, I think the way to start out is don't add Cascade and then start adding it in where you do need it. And that will help avoid issues. And I just want to check in to see if folks have questions around the behavior of Cascade.
Can you use Cascade for things that are not tables? Like, could you delete the passenger using Cascade and automatically delete the passport as well?
Yeah, I'm pretty sure you can.
I think I think it's kind of easier to visualize if you would just drop all the tables at once and then put cascade at the end than dropping tables like, sporadically throughout the table or throughout the SQL file.
Say that again, Jason.
Oh, I would think it'd be easy. So in line one, I would prefer like I would think dropping all the tables at once and then use the cascade value as opposed to having dropping at different points in the SQL file just for like understand just for readability.
Uh, yeah, I could see that. It depends. I like this pattern because I like having like when I'm constantly running this file, I like that I have the drop for the table right before the create, just so I kind of have everything I want to like modify in one spot. But it's really dealer's choice. Um, so what we can actually do, as to your point, Tim, is let me make sure I get this. Yeah, I'll put it here. I can add a rule on the foreign key. And if I say on delete cascade, then I believe what happens is when I delete a passenger, and let's run this again. And I've got a passenger. Let's insert into passport. Some values. And now if I do, I actually have to go up to get my delete statement back. There we go. From passenger where ID equals 1, that now succeeds, right? So this is the way that you would do what you were saying, where we can actually set the cascade rules when we define our foreign keys and our table definitions. And this kind of makes sense in this scenario, right? Where if I'm deleting a passenger, maybe I want to delete their passport info as well. because I probably don't want like a passport floating around that doesn't belong to someone. But imagine it's not passports and passengers. Imagine it's like cars and owners. Um, you know, if and like you were saying the other day, like it's a vehicle registry database, I might not want to cascade, right? I might want to have the car stick around in the database, even if we're deleting an owner from the database. So there's like no one clear-cut answer when you should or shouldn't use cascade. Um, I think the simplest approach is, try to kind of think about it as a real world scenario and what would make sense. And there's not always one right answer. Um, in this one, it probably makes sense that if I'm getting rid of a passenger, I also want to get rid of their passport, right? But if instead of like passport, if this was like maybe a flight record, I probably wouldn't want to get rid of that, right? Truth is, we wouldn't want to get rid of the passenger at all. Often you just like deactivate a passenger rather than delete it so that you can maintain your records. And we'll see this show up later with users. Um, Let me switch gears though, and let's look at one-to-many and many-to-many relationships. And I apologize, I do have to go in a little bit for a meeting, but I think we should be able to get through the main stuff to cover here. Um, so really the only difference between like a one-to-one relationship and a one-to-many relationship is a uniqueness constraint. Um, like if I add unique here, that's really what we need to force this to be a one-to-one. Without this, I think this would work just fine, allowing us to have multiple passports. The many-to-many relationship, I think, is like the more interesting one to look at and also the trickier one. So I think I just want to dive into that one. And we can in fact see a couple other relationships along the way. And to build this one out, we're going to use the example of students. So let me just go ahead and close these out and make a new database here, just so I have a fresh workspace. And let's start making some students. And I'm going to borrow a little bit of information here because this is all pretty similar. And we're going to put it in here for our students. And I am going to put a cascade on here for simplicity while I'm developing and writing code. And so our student has an ID, our student has a name, and our student goes to a university. Which also has an ID, and it also has a name. And now we can add a foreign key constraint that's going to connect students to universities. And this actually gives us a many-to-many relationship, because I'm not adding a uniqueness constraint, there's nothing stopping me here from adding multiple students to the same university. A student also doesn't have to belong to a university, which is more of a design choice for simplicity. But I can go ahead here and insert into university. And let's insert into students name and university ID. And I know since my database is empty that the university is going to have an ID of 1. And we're just going to send Alice and Bob to Purdue. And hopefully now I should be able to successfully run this code. And if we look at our students table, I've got 2 students in there, both attending the same university. So far, so good. And I have a one-to-many. And if I wanted to make this a one-to-one, I could have added a unique constraint here, right? Because then 2 university IDs with the same value would have violated the unique constraint. And that's how you set up a one-to-one versus a one-to-many relationship. The many-to-many relationship is a bit more interesting. To set this one up, we're going to need to create a course that students attend. And I'm going to grab the same ID that I've been using for everything. And we're going to give the course a name. And the course name has to be unique. And we'll keep it simple. That's really all we need. And let's make a couple courses. We'll do a math course and an English course. And just to run my code to make sure I don't have any typos, we see that we've got our courses in there. And so now the question becomes, how do I connect students to courses? Right, because over here, I've got Alice. And I've got Bob. And over here, I've got math. And I've got English. So we talked about this yesterday, but we didn't implement it in SQL. Can someone remind me, like, what's the technique here for a many-to-many relationship, just in terms of tables and schema design?
I believe you make a new table that has student ID and the course ID, which will connect them together almost.
Yeah, exactly. Exactly. Thank you. Thank you, Noah. And we call that a join table because as we'll see tomorrow, when we create join queries, we can use that table to combine stuff.
Sorry, what was the name for that table?
Oh yeah, the term is like a join table, as in the SQL join statement. And let's say here that math has an ID of 1, English has an ID of 2, which is probably correct. In fact, it is. And Alice has an ID of 1, and Bob has an ID of 2. So this is Alice in math, right? This is Alice in English. This is Bob in math. And this is Bob in English. And the good news here is this is pretty friendly to create. I am going to give the join table its own ID, which is a good practice. And student ID will be a big int, and it will have a foreign key that we will call back. We're going to call it student ID. And we'll make another foreign key. Now, what I can actually do if I want to here is, it's a little bit of dealer's choice if this is a good idea or not, but I can do something called a composite primary key. That would look something like this. And I'll talk about why we want to do that in just a moment. And it might be easier, in fact, to write this code a bit like this. So now, oh, excuse me. Let's enroll Alice in English. Let's enroll Alice in math. Let's enroll Bob in math and Bob in English. And let's see here, relation student course does not exist. Stuff already exists, yada, yada, yada. I forgot a semicolon at the end of line 35, and I have a trailing comma. Let's try that one more time. Another good reason to run my code as I go. Error already exists. Line 3, student ID big int. I'm missing a comma here. And let's see what the other here is. Relation student does not exist. Relation student course does not exist. Duplicate key value. Oh, I'm running into. Let's comment out this stuff because we already have our students and it's throwing errors and it's cluttering up my error messages. The other ones I can ignore a bit more easily. And let's do a quick sanity check here. And it looks like student, I goofed in the name and I named the student table plural. So now let's run this again. These relation already exist messages we can ignore. Insert or update violates foreign key constraints. Let's see if we have anything in the student courses table, because it may have already been put in there. So, let's see, we're almost home here. It looks like the issue is here on line 37. A foreign key constraint, student course, student ID. I might need to simplify this a bit just to get this working. Because I think we're almost there, but I think I have a syntax error hiding somewhere. And it might be with the primary key. Let's see what that table looks like. So this looks okay. This is kind of what we want to build here. We've got a student ID, we've got a course ID. They can't be null, which is what we want. We have a composite primary key. And the goal of that, by the way, is to avoid the student being enrolled in the same course twice. Like if you folks look over here on the right with tail draw, we have Bob. He would be enrolled in the math class twice, which is not what we want. But by building a composite primary key like this out of these two foreign keys, we're requiring this combination to be unique. Right? And that's what we see here with this index. And these foreign key constraints look good. Let me try doing this manually.
I could be completely wrong, but is it a question of you're initializing the primary key, in line 30 before you even mention lines 31 and 32?
Oh, that would be nice if it was it, but I don't think the table would have been created if that was the issue. I think SQL may be able to like read the whole statement in and evaluate, but let's see if this doesn't work. I may circle back to that because that is a good point. Let's try adding Alice to the math class. Insert or update on table, violates student key constraint, student course. Oh, it looks like there's no student data. That would be the problem. And there's no course data. I wonder if I'm running into other issues here, but I think the quick and simple answer to this is some copying and pasting just to get this working. I suspect I probably had a couple issues there. And you can see how, like, once I got my singular versus plural table naming convention off, it's really thrown me. So math and English are in there now. And if we look at the students, they're in there as well. And now let's try an insert into student course. And now that works. So I think I had a couple, there was some syntax issue hiding in the SQL file that I couldn't find, to be honest. But then the issue was that the student data wasn't created. But now we can see Alice is enrolled in English we can enroll Alice in math. If I try to enroll Alice in math again, we get this duplicate key constraint violates unique constraint, which is awesome because this composite primary key means we're looking at this unique combination. Sorry, I just had to respond to something quickly. And now we can also add in Bob, right? And we can add Bob into math, and let's add Bob into English. And this is our join table right here. And you can kind of see where the term comes from because we are joining these two foreign keys together. So to recap, to create a many-to-many relationship, we need to make a join table. Sometimes we might want a separate ID of its own. That's not the worst thing. In this case, and for learning purposes, it's also good to see that we can make a composite primary key. Another way I could do this if I wanted to was I could add the ID and I could do, I believe, constraint unique would do the same thing to add a unique constraint on these two columns. That's a good point, Jason, about the order of this stuff, but I think SQL is just reading everything in and can kind of figure it out. And then we have our two foreign keys, and that's what connects the student to the class and the class to the student.
So when you select star from student course, because of the way you initialize primary key, you're not going to see it. You're not going to see that value per se, as its own attribute when you do select star from student.
Yeah, exactly. This is actually a constraint. We're not actually creating a column. Like the same way foreign key is actually sort of a constraint on a column, like primary key is a constraint, and we can set it to different things. To be honest, I think it's honestly a bit of a better pattern to have a primary key ID and have this just be like a constraint. And I have to double check, but I'm pretty sure the way you would write that constraint is like this. Where, and we can put it over here sort of for readability, where we have our primary key, but we're also adding a constraint that the combination, this tuple really of or maybe set of these two columns has to be unique. And that's how we make sure that a student doesn't enroll in multiple courses. What other questions do folks have around many-to-many relationships? Because this is sort of the big one for today. How are we feeling?
Seems
Cool.
pretty straightforward.
Yeah, once you break it down, it's straightforward. As you kind of saw with my debugging, the devil's in the details. And I think the tricky bit is it's not just the SQL code, but it's also the data in the database, right? Like the error that I was running into because the students didn't exist when I thought they did, that's a really common gotcha. So, I didn't add like as many drop table statements in here as I wanted. It's not the worst idea to like have your insert statements for SQL be in a separate file and have like one file that does all of your table creation, because then you can run it really nicely and then you can run the other one and it probably makes it a bit easier to debug. I do apologize, folks. I do have to hop for a meeting, so let's stop here.